Hi there. Today I'm here with Marino Wijay. He is a DevRel, DevOps, and also conference organizer. I'm very excited to talk to you, Marino, about everything DevOps and community. How's it going?
Going well, Bass. Thank you so much for having me on the show. I'm really excited to just talk about whatever we want to talk about.
Yeah, thank you. So then let's just jump right into it.
Yeah.
Tell us little bit about like your daily work and what you do.
Yeah, so something interesting that I'll share is that I'm actually starting a new role on Monday, of
Oh,
Monday, December 1st. So folks that are watching this, I'll already be a week into the role, I imagine. Um, but for the last year and a half, I've been at a company called Kong, and I still will be at Kong. I'm just doing an internal
mhm,
transfer to a different team. And in that last year and a half, I've been focused on direct customer and user work, meaning design, architecture, implementation work around a lot of what Kong does, specifically in the API management space and
mhm,
even in the service mesh space as well. And even more recently, some of the AI magic that's been going on as well. And what that really means is when an end user decides they've got to solve a set of challenges or problems, or they've got aging technology and they need to replace it with something a little bit more modern or a lot more modern and
mhm,
more agile, more flexible for their needs, and even much more featurific, that's where Kong has come in, right? And they've bought a set of technologies that they want to implement into their environment. Now, interestingly enough, the end user I've been working with is massive, and I I don't know if I should drop the name because I'm sure folks can go investigate and find out who it was. But there's such a large enterprise that they have so many different teams that we have to work with, and all those different teams require a good amount of communication and coordination, as well as some management, if you will. And the reason why that is because I have to act as a bridge, even though I'm also a technical resource or an architect to effectively help them decide how they want to implement the technology. But starting next week, I'm moving a little bit further up that line into the pre-sale side. So
mhm,
something I've done before, solutions engineering, and I've done this previously in other roles as well. But what that really focuses in on is a little bit more of let's design it ahead of time before you decide to purchase and make sure we've adjusted and addressed all of your like constraints and design requirements and it fits your specific needs as an end user. And if it does, great. Like, sign the check and we'll be on our way.
yeah,
But being in that kind of role also allows a little bit of that developer relations, a little bit of evangelism, a lot of technical design, a lot of customer and user facing work as well. And it's exciting because it's a very highly dynamic role. And, folks thinking about where they should go next in tech, solutions engineering is definitely a place you'd want to consider. Now, also, I'll talk a little bit about the community side as well, because for the longest time, probably for the last 4 or 5 years, I've been heavily involved in the community through a variety of different means, attending events, speaking at conferences, hosting things like Twitter Spaces, which I haven't done in a while. And that's
mhm,
primarily because I just haven't had time. And trying to find the right time to do it is always a challenge too. But it's a little bit of that. It's a little bit of connecting with the community and
mhm,
just understanding how they're building, what they're building, where I intersect with what they're building too. Because at the end of the day, a lot of people are building, they're developing, they're building applications, and a lot of those applications are consumed using APIs. And then when you think of the infrastructure side, a lot of those applications need to be hosted somewhere, whether it's the cloud or in an
mhm,
on-premises environment. And that's where I fit in. That's where I come in because I'm a connectivity expert and I come in and really help people understand why that application needs to talk to that one and what needs to happen in between, especially when it comes to security guardrails and just higher performance or higher availability. So that's really where I focus in on. And then I've also done a number of hosting events. I've hosted conferences I've hosted a lot of meetups within the Toronto area because that's where I'm from. And I actually will be having a conference coming up very soon next year called KCD Toronto, or Kubernetes
Oh, that's
Community Day.
awesome.
Yeah.
Yeah, I mean, when I think of Kubernetes, the one name that comes to my mind is actually yours.
Okay.
So,
That's good.
and when it comes to Kubernetes, the next buzzword is DevOps. And
Mhm.
you mentioned a lot of the aspects already in like this short introduction, like solutions engineering, like scaling teams, like API management and stuff like that. So help me a bit of unwrapping the whole landscape, because when I, for example, look at the CNCF landscape, I find a list of technologies that's probably longer than the list of libraries I use in my app. Also, like DevOps is a bit more than just Kubernetes and a bunch of YAML files. So help me unwrap that a little bit.
Yeah, absolutely. So let's think of a home for a second, right? A home is on a plot of land and it's real estate. And normally that real estate is very fixed. You can't really increase the size
Mhm.
beyond what your plot of land is. So if you've got like a 1 acre plot of land, you can only build on top of that. And even then you've got restrictions. But inside of that home or house, you've got different rooms, you've got different equipment, you've got a kitchen, you've got a kitchen island, maybe, you've got several bathrooms, you possibly might have a basement, depending on which part of the world you live in. Because in Canada, we have basements as a thing, which is a sub level. And then you have to think about how you make this all fit together. And that's part of it, right? That's effectively planning this all out and architecting a house that supports all of these specific needs. And that's very much what developers and DevOps teams are doing. So you have developers that are writing code, developing applications, and they need to find a place or real estate to put these applications on. Normally that'll be the cloud or some provider like Vercel, or something that is highly managed. So all developers need to do is just um, point to their repo, and everything just kind of figure itself out, basically. But then when you start to get into some more of the complexities of customizations, because sometimes we can't just land our code in an environment and expect it to run, we also have to think about how we do some level of integration. So a developer will write code, and then someone else has to take that code and run it somewhere. And like I mentioned, cloud is a good place, but if you want a lot more customizability, you're probably looking at systems like Kubernetes, for example.
Mhm.
And Kubernetes is just another real estate. It's just another form of real estate where you can host these applications or services, if you will. But the thing is, when you deploy an application to Kubernetes, you're not just imperatively saying, I want you to run this. There's a declarative nature to this where you're telling Kubernetes, I want a desired state, and I want you to always maintain that desired state. And so Kubernetes honors that. If I have an application and I have 3 copies of it, Kubernetes as an engine is trying to make sure that it always has 3 copies of that. But in order to make sure that's possible, you need to consider things like networking. You need to make sure you
Mhm.
have the right observability in place. You need to make sure that you have capacity available to run 3 copies of your application. And most of the time, when you're running Kubernetes, you're running an application in the form of a container. So a lot of developers are probably very familiar with Docker as
Mhm.
a tool to be able to package their applications up and make them available to a lot of other developers. And Kubernetes is just a place that runs those containers, those Docker images, if you will. I mean, there's other formats of container images, but Docker seems to be the more prevalent one. Now, DevOps as a practice is actually in a lot of ways kind of it's advanced. I mean, it's moved along, and now we call it platform engineering. And the reason why that is because when you have this concept of platform engineering, it takes the ideals and ideology of DevOps,
Mhm.
but marries it to something like automation and removes the blame of an individual, and it's more so around the process that just needs to be fixed. DevOps is more of a culture of let's deploy something in a very iterative sense, but when something breaks, let's fix it so that it doesn't break again. Now, platform engineering is just a deeper, larger extension of it, where you're using concepts of pipelining, CI/CD. You might have heard of that term, where you're continuously integrating new features, capabilities into your application, and then at the same time continuously deploying or delivering those applications to make them available to either your end users or maybe internal teams, if you will. Now, the idea of platform engineering hinges on this concept of automation, right? Automate as much as you possibly can so that you remove human error, right? Because one mistype of the finger means that something might be out or down, and we've seen that happen time and time again. Or maybe some form of code is pushed to production and effectively breaks production because it wasn't properly packaged or didn't have the right hooks in place or integrations in place, or there's so many different considerations. Maybe it wasn't memory safe to begin with, so it just created a bit of a denial of service, consuming all the available memory and CPU on the real estate it's been running on. But that's effectively what DevOps is really about, and even platform engineering. It's about taking all of those applications and putting it through a life cycle so that you can continue to iterate in smaller chunks, but still have your larger application deployed to production, and you can make changes without really impacting anyone's behavior. And then the fixing side comes along too, that you improve upon that overall life cycle so that there's less issues, less tickets, your mean time to resolution has been decreased significantly. I mean, there's so much more. There's the technology side, and then there's the culture side.
I love the analogy to the real estate. That's pretty helpful, and I love the focus on automation. I want to dig into that topic a little bit, because like the more you automate, the better you sleep when you deploy to production on a Friday, right? So what is to that automation process? I mean, we've all heard of automated tests. We have all heard of automated deployments. Is it really as simple as writing a GitHub action workflow with run tests and then deploy, or what is the magic to it?
I mean, that's effectively it. GitHub Actions is a very specific example of it. But the idea behind automation is that based on certain triggers, there's new code checked into Git. That's a trigger for the deployment to run again, because there might be a new feature that's added and merged to the main branch. And effectively, that trigger itself is what tells the environment, okay, go and deploy this new feature and make it available to everyone. But automation just removes us from having to go click and manually deploy. Now, there's different forms of automation. For folks out there, you might have used Python to automate things. Heck, you might have used Python to automate your home expenses, if you will, and make sure that it can import everything from your bank account right into a set of statements or spreadsheets so that you can better understand like where your money is going or how you're spending it. That's a classic example of like how everyone would use automation just to simplify their lives. But automation gets really advanced because if you think about the infrastructure side for a second, you're not going to manually deploy infrastructure anymore. You're going to use something called infrastructure as code, which helps automate the deployment of that real estate. So whether it be EC2 instances in AWS or a Kubernetes cluster that runs in Google Cloud, infrastructure as code is really helping with that. But that's part automation. That's part of it. Because you also need triggers, like I was just talking about. When someone makes a change to how that infrastructure should look, they're not directly going to the real estate and making that change. They're changing it in their version control system. And that's going to reflect back into your overall real estate. It's not almost immediate. Sometimes you have to think about that testing too. This one change I made in my infrastructure as code, Terraform, for example, is a perfect example of IAC or infrastructure as code. we have to make sure that it doesn't break anything else. So we have to test it and validate it and ensure that it doesn't. And if it does, well, that deployment altogether is going to fail, and we'll backtrack so that we don't affect production. Same thing happens with code, right? When you're writing an application and you're going through your automated testing and you realize like this feature is going to break a number of other features or capabilities, could be something we missed. Well, one, you're going to have logging information to understand why it broke, but two, you're not going to affect production or the production application because you'll revert those changes before it even gets pushed to the production environment. And normally this happens like in your earlier environments where you've got a dev, you've got a QA environment even where people are validating that things work the way they should. You've got a staging environment where you're doing like load tests against your code to see how it handles under certain load. For example, you might be ingesting 1,000 requests a day, and then you want to ensure that it can go up to 10,000 without breaking or falling over. And that's the scale side of it too. And that scaling also needs to be automated in a certain way as well. So for example, if I want to ensure that I can receive 10,000 requests on my production website or production application, but initially it's only able to support 1,000, well, I have to scale up the environment. I have to scale up the number of copies. I have to have some form of scaling to ingest those additional requests. And that might just be a short-lived thing because I also want to scale down, right? I also want to make sure that I'm not running things forever because there's the cost side to it too. When you run in a cloud provider, if you scale up your EC2 instances or your ECS containers, for example, up to 10,000 or 5,000, whatever arbitrary value, if you don't scale it down, you look at your cloud bill at the end of the month, it's like, okay, my utilization is not as high, but I have all of these different
the resources
exactly
deployed already.
Exactly.
So basically what you're saying is that part of the deployment process in your CI/CD pipeline is also defining the infrastructure, preferably with like tools like Pulumi, Terraform, or other ISC tools. And then those hit those cloud providers or a Kubernetes cluster. And what you're defining there, what you're configuring there, are very small primitives. You mentioned, for example, customizability and different network configurations and stuff like that. And all of that, to me, sounds like for a regular application, there are only so many ways of meaningfully do such things. And to me, it seems like this is exactly where those providers like Vercel step in. Like they reduce the burden of having to configure all of these small details by yourself, and they just set up the triggers for you and say, okay, you want this code run on this HTTP endpoint? Sure, let's go. So would you say that providers like Vercel, there are others, of course, that they or generally serverless configurations, Cloudflare does a similar thing. Would you say that those is the natural progress to what Kubernetes was to bare metal? Do you think that we even care less about infrastructure because we are just relying on a provider for that?
Well, yes and no, right? Let's look at it. Let's break this down for a second. So to get something into production, or to, I guess a better way to look at it is to see revenue very quickly, you're going to want to use something that is very easy to deploy to, very quick to make it available to others, and then you can start seeing your revenue. But with that level of loss of control, if you will, like I've got a platform, I deploy what I need to, and then it's there, it's out there. You lose a lot of control. And for smaller organizations, startups, if you will, that's fine initially until that startup grows. And then things like compliance comes in and hits and says, oh, you need X, Y, and Z to be compliant, both from a tax point of view, maintaining things like GDPR, which is something that is in Europe, or even handling things like PII or even PCI-based environments, personally identifiable information, payment card industry information as well. And when that hits, sometimes you start to realize like these providers that give you a platform to run your code, Heroku is one of them too. You need some form of control. You need to be able to customize. And then you also think about the industry you're aligned to, who you're selling to. And some of your bigger buyers are going to come back and say to you, I need this, 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 this to make sure that I can run my application in your environment in production. And then you start to realize sometimes systems like Vercel, not specifically Vercel, because I know it's very customizable, but systems like it, other environments don't scale to that level of features or capabilities. And then you have to think, okay, now I need to start custom building. Because as you've taken on newer end users and customers, they have specific requirements. They need you to meet compliance requirements. That means you have to evolve out of the real estate that you're on top of, which means Kubernetes tends to be an option. Now, I'll also admit, not everyone should just jump to Kubernetes. Startups should never touch Kubernetes right off the bat. Like it's just additional overhead that requires expertise, understanding how intricate of a system it is, and understanding all the different pluggable layers that need to go into something like Kubernetes. And sometimes you might consider a very highly managed container system like ECS or Google App Engine, if you will, as examples of where you can still run your code, have a good amount of control, meet your compliance requirements, and keep your customers happy. And that's really a trade-off, right? You're giving up a lot of control for something that's highly automated and managed, or you're taking on more control, but then you're going to have to layer in the expertise, but you get complete customizability. But then you also have cognitive overload too, because there's so many additional things you have to think about and manage as well. And that cognitive overload comes from the fact of, okay, I have to not only manage my code, lint it, validate that it passes tests, but I also have to make sure that the infrastructure is healthy at all times. I have to make sure I have the right observability so that I'm getting alerted when something goes down, because if something goes down, that's revenue impacting in a negative way, right? If something is offline, your hourly ARR or hourly recurring revenue might shrink to zero, if you will.
If it's down, it's down, right?
Exactly, right. And that's where it starts to really come to a head, where you realize there has to be a good balance or middle ground. And this is where architects will come in and evaluate what is the right and best fit for you. Startups, probably using something like Vercel or another managed engine is great to start, but once you need to scale and meet those compliance requirements, something bigger and beefier is likely appropriate for you. When you have to think about globalization too, and you need to make those services available everywhere, sometimes the engine that you're using today might not be able to get you there.
Yeah. So I see now like three different dimensions to look at. The first one is like you have like the obvious things like Kubernetes tackle is like scaling and traffic. You have a global coverage of your endpoints, like redundancy built in and stuff like that. So that's technical. The other thing that I see is like your team size. Like you need not to scale only for traffic, but you need to scale your organization practices for your team size. And the third one that you mentioned is like compliance and regulatory needs that needs to be addressed. So depending on where you are, that might or might not be like one of your concerns. What do you think is like the sweet spots where smaller teams that are just starting out should start to care for those things?
Yeah, without being very technology centric, that sweet spot is really what can get me going very quickly, but still enables me to have access to a lot of the toggles and visibility into what's actually going on under the hood. And that's going to be hard, really hard to evaluate, because you might hire someone to come in and handle all of this for you, or a team of engineers or architects or both to come and figure this all out for you. But that balance is really finding the difference between how much you're charging for your services and how much revenue you're capturing and how much it's actually going to cost you to run all of this too. There are systems out there that are, again, highly managed and can cost so much because you're trading expertise for something that already does it very well in an automated sense. Whereas on the other hand, you're bringing in knowledge power of individuals that effectively are knowledge workers. They know a lot about a lot of different systems and can come guide you to, where you need to go. And at the end of the day, like, there is no silver bullet to all of this. There is no answer to making sure that, a big organization like, so I work in Canada, and let's take a bank, for example. A lot of the banks are unlikely to use cloud services, or they'll use a small subset of it, and it's mainly for compliance reasons. And so they weigh out things like, okay, if we have a breach or if we have data loss, well, how much does that impact our business? How much money do we lose versus, we have everything in-house. We have a lot more control over it. But a smaller enterprise or a smaller organization won't probably have those same kind of concerns or challenges. Now, here's the reality. There's no silver bullet, but when you think about every organization out there, they haven't thought out everything, right? I'll tell you something really interesting. So AWS publishes a well-architected framework for how you should run your applications on AWS Cloud. And what's interesting is, for some reason, everyone decides they're going to default to using US East 2, one of the first
US East 1.
Or 1, right?
Yeah.
And what happens is they plug in all of their applications there, and they keep pushing that high availability aspect down the road until the region goes down. There's a region failure. And we've seen it, like, we've already seen several regional failures in the last 2 months alone, which is surprising, which means organizations are thinking about, let's get to the revenue quickly, and then we'll address the other challenges down the line. And then it comes and bites them in the butt later on, and they realize, okay, now we have to backtrack and think about how we can make this highly available. But that in itself comes with a whole level of complexity. And so there is no balance. There is no silver bullet to making sure that, a team can come in there and just pick one solution that'll address everything. There isn't an answer to that, unfortunately.
Like the usual consultant answer, like, it depends.
Exactly. It depends on a variety of factors, right? You've got to consider trade-offs and what you're gaining from those trade-offs.
Okay, let's try to dig more in the technical side of things. Let's say you have all these microservices, you have like a application that relies on IAC tools, does a lot of automation. What tools are there for developers to tackle that? I mean, like in the old days when I had my Rails application or Django or Next.js or whatever, I type npm dev, Python run server, Rails run server, something like that, and my entire monolith would start up and I can make changes, I see them. Replicating such an architecture for a developer can be quite challenging. So how do teams work with those services?
So teams can continue to work with those services. It's just how they do it and where they do it becomes a little bit different. What's really nice is that when you want to compile code and you want to make sure that you run it, you can automate a lot of that, right? GitHub Actions is the perfect example where you can run npm and it can build your server for you and then run it and host it, where you don't have to do this locally. You just port your code and provide the instructions on what needs to happen afterwards. And normally what's supposed to happen, especially in enterprise environments where they're using a lot of automation and using things like Kubernetes or specifically Kubernetes, a lot of what goes on is developers really just focus in on having a very small contained dev environment, right, where they can test the functionality of what they built. And then when they feel and deem that it's, completely fit, then they can send it off to that main branch. And then there's systems out there that go and look at that code, will package it up, put it into a Docker image. That Docker image is now stored somewhere, whether it's a local Docker repository or a container image repository. And then there's another system that comes in and has a manifest that says, I need to run this application with these dependencies. In order to do that, I need to pull that container down, wrap it in such a way, might be a pod in Kubernetes, and then deploy it to Kubernetes in such a manner so that it can accept connections from other applications and it runs wherever it needs to run. But then after that, now you actually have to think about instrumenting your observability as well and ensure that as the application is run, you're heuristically looking at the data of logs, the metrics, even the tracing elements too, because what you're going to find is that log message will tell you one thing. They say like, okay, there's this error or there's exit code or something like that. Traces will tell you how services and applications are interacting with each other. And if I have several services in a request path, so for example, my web browser is going to go to an API. That API hits another API on the back end, which hits another API on the back end before it returns a response to me. We're going to have to monitor to see which one of those APIs or microservices, or even services, if you will, are being starved of resources, or they might be taking a lot longer to process that transaction altogether. That's latency. So once you've instrumented your observability right into your applications, you now have an idea of where that latency lives. And then now you have to go and fix it, right? Now you are a developer who's taken back that code and says, okay, I need to make some of these modifications and some of these functions, maybe optimize the code a little bit, reduce the lines of code. And now I have a much better performing stack or application that gets repushed back out into production. And then you begin to realize like, okay, now my latency has shrunk from like, I don't know, 10 milliseconds down to 2 milliseconds.
Yeah. So I want to circle back a little bit about this dev environment that you mentioned. How does that look like? Is that living on a cloud provider in a Kubernetes cluster? Is it run locally? Like, how do I get like the actual code to run when I'm just on my laptop and changing things to a single endpoint?
Yeah, so there are a few options for that. And that's going to depend on your organizational policies too. Some organizations say you can run something like Gitpod. I don't think Gitpod's called Gitpod anymore. I think it's called something else.
They rebranded, yeah.
Yeah, so they rebranded to another name or something. But Gitpod is a good example or a classical example where you define all of your dependencies in this small developer environment where you can run your code, it'll compile, and then you can test against that code to understand what it is. In your own environment, there are similar styles where you can run a dev container or I think GitHub has something, or VS Code has something built in as well, where you can actually run that container instance locally. Docker is another example, and effectively just package your code the same way you normally would, just to simulate what your output is going to be when you communicate or talk to your application, if you will. What I also think, though, is that a lot of organizations, while they want to enable their developers to do so, those compliance requirements come in and hit. And a lot of times developers will say, hey, it works on my system. Why doesn't it work elsewhere? Well, it's because in your own little system that you've developed and you've added all the necessary dependencies and packages that you needed, well, the thing is going to work because you knew ahead of time what was all needed. So there's a little bit of an element of defining your design requirements to make that application function. And another system that takes in your code has to be able to know what those dependencies and packages need to be present in order for it to run elsewhere or in another environment. I also believe that what's going to happen more and more frequently is that we're going to see a big push for teams to just start using cloud-based services to test out their code versus using something local. And that's strictly policy related. That's strictly because there's a lot of challenges going on where AI has entered the conversation and is writing code for us, which is sometimes allowed within organizations, sometimes is not allowed at all, because that can actually introduce more problems, more challenges, more bugs, if you will, that a lot of organizations just don't want to take on because it's added cost to them. And so they'll use external systems and external dev environments for you to start building on top of. And then it can go ahead and determine, is this AI written garbage, or is this actual legitimate code that you thought through, designed for, and on top of it, it fits into the guardrails that we've put in place so that it functions in a very safe manner too. And then you also have to think about, oh, sorry, go ahead.
There are a couple of like competitors to Gitpod as well. I found one which advertised its main functionality as not being able to copy and paste code. So yeah, that's probably all coming down to those policies. A very interesting way to look at it. But that raises another question. Like, you only can learn such things if you are working for such an organization, because nobody's caring for like regulatory affairs if they don't have to. Nobody's caring for scaling if they don't have to. So what is a good way to learn all of those things? And this is also like, what are good communities to exchange thoughts and to exchange best practices?
I honestly think that there are so many different communities out there, but the best ones are 100 Devs, for example. Is a great place. It's a great one where you're not only going to learn the basics, and you're not only going to just build a hello world app. You're actually going to be working with multi-component applications that require things like authentication and authorization, where you're going to instrument observability, where you're going to learn about memory safe code, where you're going to decide like which is the best language to actually use for this use case. And while it won't always get you to what an organization is doing like 100%, it brings you so much further along than some of the other communities that I've seen out there, because there are communities out there that do a lot of evangelization, a lot of foundations that are heavy on the evangelization, but not so much on teaching people the right set of skills to actually be successful in an organization. We're in a bit of a catch-22 here, where you have enterprises that are, not to discourage anyone, aren't hiring as much on the junior side as much anymore. And because of that, juniors are not able to be exposed, or early career individuals are not able to be exposed to some of the more enterprise challenges that occur out there. So there's a lot of people that publish videos on some of this stuff as well. Not only communities, but people that have built out YouTube channels that go into a level of depth that no one normally would. Like, we're beyond using a for loop and building some functions, or using like, we're at the point where we have all of these different components interacting with each other. How do we run a test? How do we build tests? How do we automate those tests? How do we also ensure that we can debug better? How can we read log messages? Because these are things that are happening in the enterprise too. And I'll give you a good example. When there's a bug in the software for the company that I work for, right? I mean, every company is going to have bugs in their software, and you see it firsthand during implementation. You have to capture a lot of details. You have to understand what's going on, why it's happening, what triggers that bug, what set of operations led you to that bug. And then you also have to decipher log messages. And one of the best ways to learn how a bug is triaged and fixed is to see and sit alongside developers that actively work on these products to understand their thinking. Like, maybe someone messed up somewhere earlier on and didn't really think about it when they were building out a function or a stack, and then realized, oh, okay, well, I shouldn't have done this. I'll rewrite this function and now it performs the way it should, or they miss like a set of like parameters or variables where a system is looking for logic and it can't find the additional parameters or variables anymore and can't complete the logic anymore and provide the right output, which then is a bug. So sitting alongside developers, and then now you go look at uh, their pull requests that they write up and define for the changes that they need to push into the main branch is very telling, right? Because when you look at open source technology, CNCF is great like this, the Cloud Native Compute Foundation. There are so many projects, and even not just sandboxed or incubating, but even graduated projects, where if you go look at all the issues that have been opened up, you get a sense of what are some of the problems people are trying to solve. And what happens is in those issues that have been defined, it's not just, okay, here's an issue, this thing's not working, fix it. It's more like, here's the issue, here are the symptoms, here's what I did to create this ultimate bug or issue that's going on, and here's the environment that I created it in. And then you'll have a number of comments come in that are saying, oh, did you try this? Or, oh, this is new to us, or something to really give you a good read on how that problem is going to be solved. And then at the same time, when that issue is discovered, some people that even open up those issues, they've dug into the code and then realized, hey, you could solve it this way. The same people that create the issues are the ones that could also solve it, because they probably already looked at that open source code base and realized, like, well, okay, now I know how to do this, or now I know how to solve this. Here's what I propose. And then someone else will come in and see that and be like, oh, yeah, this is great. What if we just modify this a little bit, and then now we push this into the main branch and now it's fixed? That's a great way for folks to really understand how an issue or a bug or something of that nature is resolved, especially if you're early on in your career. But I'll add on to that. Normally, all these issues are affixed to a business purpose. If I don't have this feature working, or if there's a bug in this feature, here's the business impact. And that's far more critical. But one last thing I'll add to that dimension is the communication side of it. If you cannot communicate what your thinking is, that's where a lot of people, I feel, tend to struggle, especially when they're trying to get their first early career role in dev. So if you can communicate your ideas, if you can communicate the issues that you've encountered very well in a very thoughtful and descriptive manner, you're going to do really well.
Yeah. I love that perspective, because I think, like, especially the CNCF projects, they are among the best maintained open source projects out there, because there are people working on there that already follow those best practices. But when it comes to best practices, a lot of what we talked about revolves around the theme of like customizability. So if everything is customizable, then to me it sounds very hard to find best practices for that. So how do you tackle that?
So I think over the course of many, many, many years, we've determined how certain things should operate, how certain things should be built. And if we land on pillars like those, right, best practices, initial best practices, what ends up happening is, all right, you've got a very strong foundation, because everything else beyond it is going to be customized, and it's going to be customized based off of what you expect your application and infrastructure to do. Now, I'd say about like 90% of the organizations out there are very much using that same foundation in some way. It might look different for every organization, but they follow the key principles of ensuring that they've got compute, storage, networking, they've got the right observability in place, and they've addressed challenges around disaster recovery and high availability. That is a given. And if you don't have that already, whether it's through a platform like Vercel or something you built yourself, then you're already missing the foundation, or your foundation is going to crack at some point. And then it's also finding what those dependencies are, right? If you can determine every single one of those dependencies and remove it as a dependency, like we've seen that diagram many, many, many times where like that one little thing is holding up the entire
Oh yeah.
world, if you will, and it falls apart, everything crashes, right? So if you identify what that dependency is, and it's not technology alone, it could be people. If there's a single person that's responsible for maintaining that small piece, that's a bottleneck and a dependency, which you can fix by making sure that there's enough knowledge sharing going on. And knowledge sharing happens through a few ways, right? You're communicating your ideas on your version control system through comments, but documentation, right? We have documentation for a reason. And what's interesting is you can have really great documentation, but no one reads it. And then you can have really poor documentation and everyone reads it.
Yeah.
Right.
Both of that is not what you want.
Yeah, you don't want that. But you also want to make sure that your documentation is attainable, easily readable, and is able, you can understand what's going on, right? And the best way is you've got documentation paired with diagrams, paired with use cases, paired with business cases as well. And that makes it helps you achieve best practices overall. Now, there's also a flip side to that too, where at the end of the day, like a lot of people in tech, myself included, reading like a extremely long wall of text to understand something is very challenging. And the reality is like there's never a TLDR at the top that says, here's why you need to like read this doc and what it's going to explain. So you really have to go through the entire thing before you find what you're looking for. What I think is happening though is AI is really helping with that. So if you can use a chatbot or an agent to help you understand what this documentation or this doc site is trying to, maybe one specific page is trying to illustrate to you, that speeds up your learning and understanding of solving a problem. So if you can achieve that velocity by simplifying your docs a little bit better or understanding it a little bit better while following those best practices for not only like developing your code, but also developing your infrastructure, you've already achieved a lot of your best practices there. Technology, however, what's interesting is everyone has their own approach to implementation, and that's where things break. Everyone, even competitors, even if they feel like another technology is a threat, even though they might not be competitors at all, tend to delay integration as well.
Yeah.
Right. That's another challenge that we see.
So what does that mean for the trajectory of, like, let's say the technical side of DevOps? If we are going to a point where we evolve to more and better best practices, does that mean that that we have less configuration options or more sensible defaults? Or in other words, what is the future of tools like Kubernetes? Is that where it's going to stay for a while, or do we see maybe an open source version of something like Vercel, which is much more simpler, still customizable, but very much better for like a quick start? So what's the trajectory there?
So if you think about the trajectory of Kubernetes, for example, 5 years ago, it worked, but there were a lot of things you had to plug in yourself and configure and even figure out. So imagine a lot of people having sleepless nights trying to make two things work within Kubernetes, which then becomes a standard within Kubernetes. A perfect example is the gateway API spec in Kubernetes, where previously you had different ingress capabilities of getting traffic into your environment, and there was no way to manage or separate infrastructure from what developers wanted to do. A developer had to manage the infrastructure of ingress and then even define what it was supposed to do. But when you can separate those out with Gateway API, it now creates a very role-based access control model where developers only really need to care how they get how they route to their traffic, whereas infrastructure providers will say, I'll give you these tools and define what these tools can operate in as a parameter to effectively give you what you need to do to achieve your traffic routing. That's an example. And And I can imagine the same would happen for Vercel, where like you have Vercel that initially launched years ago and worked, but missed a lot of things, right? Missed maybe the globalization component, which they probably since addressed. And I haven't looked at all of the capabilities of Vercel today. But then when it becomes like a toggle, if you will, I want the AI SDK turned on, right? And what do I need to do to inject that into my code is very easy to do as opposed to maybe 3 years ago or 2 years ago. And we start to see like these toggles become much more accessible to everyone as they're trying to build or attempting to build, because now they don't have to think like, what is this toggle supposed to do? What are the implications of turning this toggle on? We see the same. We see the same with Kubernetes. We see the same with cloud. Cloud is a perfect example of that. You know, when AWS launched their cloud a long time ago, like I think I started playing with AWS cloud back in like 2011, 2010 even. And they had like a very minimal set of services, S3, EC2. Kubernetes wasn't even a thing for them back then, right? And so you're hand building things. But now today, when you tell AWS, I want a Kubernetes cluster, it is pre-provisioning AWS instances. It's there. Like it's all there. The load balancing is there. The DNS is figured out. Most of your IAM permissions are figured out. These are things that we've learned along the way that just improve the experience for both developers and even operators or infrastructure providers, if you will.
Yeah, very cool. So we did dig into a lot of like technical details there. I just want to quickly come back to the topic of community because I feel that there is a lot of communication needed between like even different enterprises, different teams, to exchange those best practices and to start a conversation about things. And apart from like open source projects, of course, there are in-person events. So what's your take on these?
You know, that in itself is a bit of cognitive overload too, because when I was in developer relations, one of the biggest challenges that I had is, where do I find out where I should go to maximize my output, right? To maximize the gain for the company that I worked for. And a lot of people think like the best way to do this is to go to conferences and speak at conferences. Yes, you're doing a one-to-many transaction where you're evangelizing and talking about something at great depth across a large audience. But another thing to consider, though, is that maybe lessening the amount of events you go to, focusing on key ones like KubeCon's a great one, reInvent's a great one, even though I'm not going next week because I can't handle the chaos of Vegas, unfortunately. Maybe in the future I might go again. But Commit Your Code, as an example, these are good events where they offer you an opportunity to learn technical topics, whether you're going to learn from people or you're actually going to speak up, because when you speak on stage, the audience may interact with you and even ask you questions that give you another dimension of thinking. But then the networking aspect. But if you can, shorten the amount of time you spend on the road or in a plane, and spend more time doing online community building too, or being a part of a community as well, means you get to interact and go a lot further. So, for example, you reached out to me and said, "Hey, let's do a podcast together." And normally, like, it's very hard to be able to do that, but that's a community thing, right? And so you find a time to make that possible because it can happen almost any time of the day, provided like the times work out. And the more online events you be a part of means that you're building yourself a large repository of just reoccurrence appearances. Like you're showing up all the time, and now that's like stored in an archive in the internet somewhere where someone searches your name, even our names together, they're going to find this podcast, right? And so if you can balance it out by attending local meetups, because local meetups are easy to get to, maybe take you up to an hour to get to your meetup and an hour back home. But you spend 3 hours, you interact with the local community there, learn a few things, network a bit. That might be your next job opportunity. You go to a conference, you're learning at scale. But the reality is conferences can be chaotic too. And there's a lot of walking and talking, and you'll learn a lot from the hallway track as well as being inside of a talk as well. And then all the online events that go on where you're just sitting there and watching a webinar, right? You're interacting with the other audience members too while someone is delivering that webinar, and you're learning at the same time. You're learning together. And then you start to form bonds with people where you all show up to the same events together. And now you have like a little group that you can learn from. That is really what community is about. Whereas what people used to think community was about is, okay, I'm going to go book my flight, go to New York City or go to Dallas. I'm going to do that every other week. And now you've got like 26 to 30 flights a year, round trip flights, by the way, where you're always on the road. And, the reality is you haven't gained a lot, because at the same time, like, all of this information is information ingestion, and it comes at you so fast and so hard that it all blends together and you don't really know what you picked up or learned from. So when it comes to community, right, I think if you've never been a part of a community, join one. 100 Devs is a great one. Danny Thompson runs his Commit Your Code community. There's the Torque community as well. There's a Cloud Native Compute Foundation community as well. CNCF's got their own little community. So if you can be a part of that, that's great too. If you're into Python, the PyTorch Foundation is another community. The whole JavaScript ecosystem has like all of these different frameworks and their own little communities too. Pick one that interests you the most and then start learning alongside people, and attend a selective amount of events where you can, if you can afford to, and just go learn with others.
Yeah, thank you. Yeah, first of all, I appreciate your time, like, for being here. That was really cool, like, after we meet doing this podcast. Second thing is, I heard rumors there is one of those selective events that you might want to join, that you might want to organize, that you might want to fly to. Tell us about that.
Yeah, I'll be quick because I do have to hop on a call soon. KCD Toronto, Kubernetes Community Days Toronto, is happening May 13th, 2026, next year. And it's a conference about community, Kubernetes, the CNCF ecosystem, agentic and MCP, and even security, and even cloud native. So if you're interested in attending or even speaking, stay tuned. I'll pop out some more details in the next few weeks, and we'll have a website up and running, and y'all can register, and we'll see you there.
Yeah, thank you so much, Marino.
Bas, thank you so much for the time. I appreciate it. And, I hope you have a great rest of your day, and hello to everyone else, and take care.
Thank you so much. Take care.